Hello students. So last time I explained you how to do indirect measurements of large size objects, and we also did its numericals. Now in this session I will explain you how to measure small size substances, like we want to measure the size of molecule, then what we should do. And later on I will explain you measurement of time also. Okay, so these are two small topics, so I will both cover in the same session. So first let us start how to measure size of molecules. For this we will be using Avogadro's hypothesis. Avogadro hypothesis says that actual volume of atoms in any substance is about 2/3 the volume occupied by the mass of that substance. See, you have got 10 cc of water. That 10 cc of water is containing large number of atoms. Each atom is occupying some volume. Total volume of molecules is 2/3 of the total volume of water, because as we know that substances are porous. Porous means there is a gap between two atoms. So that gap is telling is 1/3. So the hypothesis says that 2/3 is the volume occupied by the atoms of that substance. So using this hypothesis we will calculate first theoretically, and then we also do one experiment to find the size of the molecule. So first let us do theory. So here we are assuming that atoms are tiny spheres. Atoms are tiny spheres. So we are taking m gram of substance. So we are taking m gram of the substance. So my substance is m gram. Then m is the molecular mass of that substance, which suppose I have taken any acid or any substance, its mass is small m gram, capital M is the molecular mass of substance. Like in case I take water, then I can take 10 gram of water, then molecular mass of water would be 16 plus 2, 18. Then N is the Avogadro's number. R, small r, is radius of atom. So this is radius of one atom. And V is in volume of m gram of substance. So if I have taken m gram of substance, it will occupy certain volume. That volume is V. I have taken some substance, so I know the mass is m, volume is V, so density is rho. So rho would be m upon V. So this is the data that we will be using it. Now let us do the calculations. Now first I am calculating number of atoms in 1 gram of substance. N is the Avogadro's number. So many atoms are present in m molecular weight. So 1 gram will have n upon m. But I am having small m gram of substance. So my number of atoms would be m into n upon m. So these are the total number of atoms in my substance. Now what is the volume of these atoms? Would be volume of one atom multiplied by total number of atoms. These are the total number of atoms. 4 upon 3 pi r cube is volume of one atom. So if I multiply this, I will get total volume. And now I will use Avogadro's hypothesis that total volume of my atom is 2/3 volume of my substance. Volume of substance was V, and V is equal to m upon rho. Isn't it? I have written here na, rho is m upon V, so V would be m upon rho from this equation. Now to substitute the value of V as m upon rho, and do algebra, you will get R is equal to this answer. You will get R is equal to m upon 2 pi n into rho raised to 1 upon 3. So this is the radius of my atom. So in this manner we can do the calculations. Is it all right? Okay. So then we'll see how to practically find the, now we'll do some practical. I am taking oleic acid. So I want to find the size of the molecule, means radius of the oleic acid molecule. So what is my method, what experiment, how will I do the experiment? I will take 1 centimeter cube, 1 cc of oleic acid, dissolve in 20 centimeter cube of alcohol. So this measurement has to be very accurate. In 20 centimeter cube of alcohol, I am dissolving 1 centimeter cube of oleic acid. Then I am taking 1 centimeter cube of this solution that I have got. So when I take this 1 centimeter cube of solution, again I am dissolving in 20 centimeter cube of alcohol. So the alcohol, final alcohol will contain 1 upon 400 centimeter cube of oleic acid, because when I am dissolving 1 centimeter cube of this solution, so it is containing 1 upon 20. So if alcohol is 20, oleic acid is 1. So 1 upon 20, and again I am dissolving in 20, so it will become 1 upon 400 centimeter cube of oleic acid in 1 centimeter cube of alcohol. So this is the concentration of my oleic acid in alcohol, 1 upon 400. Okay. So then we'll find out what is the volume of one drop. So this solution, you take in a pipette, drop each drop at a time. You drop 10 drops and then measure the volume, divide by 10. So you will come to know the volume of one drop. So calculate volume of one drop of this solution. Now n drop of this solution I am dropping in a solution of what, on the surface of water. So there is a beaker. This is containing water. Here I am adding n drops to this, n drops of this alcohol containing oleic acid. Okay. So when I drop n drops here, I know what is the volume of each drop. So how much solution I have dropped? N into V. So how much oleic acid I have dropped? It is 1 upon 400. So it is NV upon 400. So NV upon 400 centimeter cube of oleic acid I have dropped here. Total volume I have dropped is N into V. Now gradually alcohol will evaporate. Alcohol will evaporate and only this small quantity of oleic acid would remain on surface of water. So this you can spread. You spread over the large area. Suppose I am spreading over the area A. How I will come to, I can measure this area A by using blotting paper, by using some thin film of paper, very thin paper, blotting paper type, so that I will come to know in which area oleic acid is there. Because oleic acid may not be uniform, may be like this. So you trace this and then on a graph paper we will measure what is the area. So in this manner I will come to know area of the film. Once you know area of the film, so means this is my film and this is having some thickness. But I have spread it to such an extent that this thickness is very, very small. So that is why I have dissolved in alcohol, so that now alcohol will evaporate and very, very small thickness of oleic acid I will get. Now we are assuming that this thin oleic acid is having only one molecule, means oleic acid is like this. This is its area A and this thickness is diameter of molecule. This thickness is diameter of molecule. Okay, so now I know that so much thickness, this is the total volume. So if I divide by A, because this is equal to, I would say, A into thickness. This is the volume of oleic acid. It is area into thickness. So thickness is this upon area. So that's what I have written. Thickness of the film is NV upon 400A. A is area of the film. So in this manner, if we calculate, if we measure, we'll get an answer of the order of 10 raised to minus 9 centimeter. So we say that oleic acid molecule diameter is of this order. To illustrate this experiment, I have given a small numerical. A drop of olive oil of radius 0.25 millimeter. So this is the radius of olive oil. It is spreading into a circular film of radius 10 centimeter. So this I am spreading over a circular film of radius 10 centimeter. So I have come to know the area of my oleic acid. So I have been given a drop of oil. So I can find out the volume of oleic acid, 4 upon 3 pi r cube. So what is thickness? Thickness is volume upon area. So thickness of the film would be volume of the oil film upon area of the film. Area of the film is pi into 10 square. I have spread over 10 centimeter. And volume is 4 upon 3 pi r cube. This is millimeter. So it will be 0.025 centimeter cube. So if you calculate this, you will get 2.0 10 to minus 7 centimeter. So this is the thickness of oil film. This example I have given to illustrate that how we get the thickness in this experiment. Is it all right? Now we will go to a very small topic called magnification. You have learned this word magnification in your 10th standard also, that final image upon initial image. So now if I will say final and size upon initial size, so that is called linear magnification. And if this is a small circle or some rectangle, if I magnify this rectangle, both is lengthened by it in this manner. So this is the area A1, this is area A2. Area A2 upon area A1 is called areal magnification. Ratio of final area of image or of body to initial. So this is area. Now linear magnification, each would be square root of areal magnification. If areal magnification is 49 times, area of this is 49 times more than this, so means length is 7 times more, breadth is 7 times more. So linear magnification. So now I will explain you how time intervals are measured. Here also the range of time interval is quite large. Sometimes the time is very, very small, of the order of 10 raised to minus 20, 10 raised to minus 24 seconds. This time is normally for unstable particles, unstable isotopes. And we may have to measure very large time of to the extent 10 raised to 17 seconds, which is the age of universe. So various techniques have to be used to measure very small time and very large time and normal times that we have been measuring. So let us try to see the principle first. See, any phenomena which repeatedly occurs after same interval of time, that example we can use to measure the time. Simple. This time measurement was established by Galileo when he saw that some chandelier was vibrating in the church. So observing that the time period for vibration is same, so he used that and he made a pendulum. so as to measure time. So pendulum is working on the same principle, that for oscillation the time taken is same. So even suppose you want to measure some time, you don't have any watch or something, you can use the beating of the heart. The heart beats after every 0.8 second. So in case you are measuring that for this activity you have taken 1000 heartbeats, so means 1000 into 0.8 seconds we have taken. We are measuring a day by observing the rotation of the earth. So when the same amount of, when again sun rises, we say 24 hours are over. So any phenomena that repeats after same interval of time, that can be used to measure the time. Like now we have got a certain quartz crystal. If we apply certain oscillating pressure to it, then from its other rectangular faces it gives an EMF which is of certain frequency based upon the frequency of pressure changes made by us. So this is how we can measure time. Also we are measuring time by radioactive particles. Like most important is carbon dating. We know that carbon will become half the quantity after its half-life, which is about 5000 years. So after, in case the quantity has become half, so means the time elapsed is 5000 years. In case the quantity has become quarter, so time elapsed is 5000 into 2 means 10,000 years. So in this manner we can calculate. For even very short time intervals, there are particles which are giving some radiation in 10 raised to minus 20 second, 10 raised to minus 16 second. So counting the number of particles that it has given, so we come to know how much time it has taken. So these are the principles which we will be using it for making our clocks for measuring time. Importance are atomic clock. Atomic clock normally contains cesium-133 atom because it is giving radiation of microwave radiation which is having time interval of 10 raised to minus 12 second. Means after every 10 raised to minus 12 second, one wave is given. So we can count the number of waves that it is giving, and we will come to know that so much time has elapsed. So this is atomic clocks. Then electronic oscillators we have made. Electronic oscillator means, like we will be learning a 12th standard, a transistor, junction transistor. So it produces very high frequency. So where the frequency is more, means period is very small. So by knowing this frequency input, and so we come to know that what is the time period, time has elapsed. Then quartz crystals are there, which when we give the pressure, they vibrate, they oscillate, and when they oscillate, so based upon the frequency of oscillation, we know the time, because their oscillations based upon the crystal is fixed. Is it all right? So these principles are used for measuring time. Now let us try to do some simple numericals on this. Like first numerical, he says 2 atomic clocks are running for the life of an Indian. He has taken 70 years as the average life. He says the 2 clocks, now after 70 years we find that their time difference is 0.2 seconds. Initially both were having, we have started from same time. Now the difference in time has come. So what is the accuracy of measuring? So time is 70 years. 70 years means we calculate into seconds, because we are asked to find the accuracy in 1 second. So 70 years means 70 into 365.25 days. 1 year has got 365 into 0.25 days, because after every 4 years there is a leap year. So 70 years is a very big period, so many leap years will come. So and 1 day has 86,400 seconds. So you multiply all this, I will get my time in seconds. And delta t is 0.2 seconds. So fractional error in time is delta t upon t. What is the error in total time? So if we calculate, we will get 10 raised to minus 10. So it means in 1 second, 1 second is the inaccuracy will come in 10 raised to 10 seconds. Is it all right? Next sum. Age of the universe is given 10 raised to 10 years. But he says the mankind existed for 10 raised to 6 years. So in case he says that the universe is for 1 day, we assume that the universe has got formed 1 day. Then in how many seconds a man existed? So we have to calculate the magnification. So age of mankind upon age of the universe would be 10 raised to 6 upon 10 raised to 10. So that will give me 10 raised to minus 4. Okay. So 10 raised to minus 4 is my age of mankind upon age of universe. So if my universe is 1, so what is mankind? So it will be 10 raised to minus 4 into age of universe. Age of universe is 1 second. 1 second means 86,400 seconds. So 10 raised to minus 4 into 86,400 will give me 8.64. So means in case universe has got formed just 1 day before, one day before, then mankind has come, live only for 8.64 seconds. So this is a sum on time as well as on magnification. I hope you have understood. Okay. So thank you very much. And next topic is quite big and interesting about dimensional analysis. That will start in the next period. Thank you.